Thank you, Pia. I will now begin our presentation of this technology called continuous electrolysis, a circular solution for waters affected by mining. Next. Helix Bios is a technological basis company created in 2015 in Spain with operations currently in Peru, Spain, Peru, and Chile, and has allies in South Africa and in Colombia for the search for new technologies for the treatment of environmental problems in mining. In a tour we did of Peru between 2018 and 2019, we were able to notice that one of the main problems, environmental problems, was the generation of muds as a consequence of treatment of water. The companies are looking for technologies that can, in a way, fit in a container and can be easily transferred to the localities where these problems are located. Okay, this led to us in 2020, in association with some technological search companies, we arrived at Free Radical Process Design, and South African startup that developed a continuous electrolysis technology called RotoWinner for the capture of metals in metallurgical processes. From conversations with them, they already have a commercial plant in a platinum mine in South Africa. We proposed the possibility of applying the technology in mining waters, and therefore, next please, we developed a study, a preliminary study that allowed us to determine that, in effect, this technology of continuous electrolysis had the robustness, the versatility, and the valuation capacity that were sufficient to propose it as a circular solution for the problem of mining waters. The solution is very versatile, can be adapted to different types of waters depending on their composition and their pH, and in all cases gives room to purified currents of products that can be highly marketable. Okay, a general vision of the process flow diagram can be seen on this slide. There will be some conditioning stages for the water, which can be optional, but the heart of the technology is a cascade of continuous electrolyzers that gives room to the production of the valued materials. In the specific case of the study that we carried out with the company Free Radical Process Design, these were manganese oxide and metallic zinc products, as well as iron oxides. The process also gave room to the generation of hydrogen, which can be recovered as an energy vector in diverse applications in mining. And of course, it generated treated water that could have applications as agricultural water. The direct cost of the treatment plant, depending on the type of water that we started with, could be in the order of $0.1 to $0.25 a cubic meter. But we need to understand that this process does not look to generate costs, but rather to generate benefits from the commercialization of the products that can be extracted from the water. That's why the recoverable value, depending on the type of water, can be between $1.6 to $7.2 per cubic meter. These recovered materials can have different uses, from high technology applications, as can be the manufacturing of batteries, to even ceramic pigments of artisanal use, very apt for communities, and agrochemicals of commercial use. Next, please. This leads to us to, from this technology, being able to create an industrial ecosystem to maximize the social impact and, of course, comply with the Sustainable Development Objectives, which are to guarantee the quality of water and generate decent work and growth in the communities. The concept of circular economy comes from the hand of, first, the industrial process of mine closure, or even the continuous operation of the mine. The treatment of those waters from the application of the continuous electrolysis technology would lead to, of course, clean water or reusable water. Eventually, if there is recovery of hydrogen, to the generation of an energy vector that's important, and to the products with high added value that I mentioned in the previous stage. Next, please. Our action plan is made up of 3 stages. Our objective is to build, for the first time in Peru, and I would dare say worldwide, a plant based on continuous process of electrolysis with recovery of high-value electrolysis products. In the first stage, we would need to carry out the specific studies for the client specifically interested in the technology. In the second stage, we would build the pilot. And in the third stage, we would carry out the operation of the pilot over 9 months with the training of the local operators that were needed to be had. And of course, generating performance reports or community engagement reports with the people of the community. And the total cost of the project would add up to $2.1 million to be carried out on 2 years. Next. Well, thank you very much for your attention, and we are at your service. You can contact us if you are interested in